So every time you have a tail, you remove it from the 1,000 pennies. Eventually you're going to get the same distribution that you would see with random distribution or anything else like that. Okay? And in fact, you would even see something that looks like this. If you were to plot, so you started with 1,000 pennies up here, and then every time you flip them, like here's the first one, here's the first time you mix them up and then pour them out, and you remove the tails, and then you do it a second, third, fourth, etc. Okay, eventually you're going to get a line that looks just like radioactive decay. Okay? And the reason why it does that is because radioactive decay is an event that either happens or it doesn't happen. It's called binomial. I think I spelled that right. I-A-L. Okay. Binomial means you only have two outcomes of an event. Either it happens or it doesn't. Okay, so you either have heads or you have tails, or in the case of an atom, it either decays or it doesn't. But if you were to compare the two, it's exactly the same. You know, if we had more time in class, I would take my jar full of pennies and pour it out on the table and show you. Okay? So what happens then is this, okay, if we observed a large sample, we would find that we have what we call an average, or the mean. Okay? So if we're looking at technetium atoms, we know that the average decay is 6 hours. Okay? Now, with 68% confidence, if something is truly random, that falls in what we call the first standard deviation. So I've got 34% on this side and 34% on this side. So, for example, if my average was 100, then I would predict that any subsequent, measurements of pouring pennies out on the table, I would expect to see this for one standard deviation. Or can somebody tell me, what would you expect to see?
What was the question?
Okay, the question is, we took 1,000 pennies, we shook them all up, we poured them out on the table, and we discovered that 100 of them were heads, 100 of them were tails, and the rest of them were all heads. Okay, so basically 900 didn't decay. Okay, but 100 of them did. So my question is, if something is truly random, this is where we use the statistics to prove that it's random. Okay? So the way that we do that, for one standard deviation, it's going to be the square root of your mean. Okay? So that means plus or minus 10. So now I have a range of 90 to 110. So 68% of the time, this is what we call a 68% confidence interval. So rather than me having to put those pennies back in the jar and then pouring them out again and again and again, eventually I can say with certainty that if I did it 100 times, 68 of those 100 times that I poured the jar out, I would have somewhere between this range of tails. Okay? Make sense? Okay, so we call that a 68% confidence or one standard deviation level. Okay, the two standard deviation that we use in nuclear medicine is 2 times the square root of the mean, or the observation. So now I have a range of plus or minus 20. So now I've got a range of 80 to 120. Now this is what we call the 95% confidence level. Okay? So if my observations are truly random, I would expect 95 out of 100 times that I pour those pennies out of the jar, I should get a distribution within this range. Does that kind of make sense so far? Okay? So this is what we're looking at with that. Now the main thing on this is this binomial distribution. Okay, because like I said, that's an event happening or not happening. And then the other stuff that goes on here, Just because it falls within this range, does that mean that it's accurate? Okay, no, it doesn't. Okay, all it means is that it's behaving statistically the way that it should, but it may not necessarily be accurate. So that's why, did I give you your test? I think I put the answers on the back of that too. Did you guys see the answers on the back? Yeah, I put the answers on the back.
Do you want them to have the answers?
Yeah, they can have the answers on that, Terry. I just wanted to kind of see what all this means here. Because it really, like,
This morning, or
what's that?
is there the radiation units that you're gonna give?
Yeah, the radiation units quiz, we'll give that after we go through this. Or would you guys rather take the radiation units quiz first and get it over with? Okay, they're all nodding their head up here that they want to get it over with.
You do? Okay.
Okay. Then we'll come back to this then, okay?